This is the second part of the calculus problem that we were working with. It's an application of mean value theorem. If you have not watched the first part, go back to the discussion page. It's in the link is in the description. Anyway, so we talked about the mean value theorem and the motivation of it, and this was the picture that we had in mind. We have a y equal to fx curve. Take any 2 points, x1 and x2. Find out the heights. Heights are of course fx1, fx2, and join them with the secant line. Maybe I can use a different color for that. So slope of the secant line was fx2 minus fx1 divided by x2 minus x1, the general equation of a slope. Height minus height divided by x minus x. And the main idea was that there is a c in between x1 and x2 such that this is equal to f prime of c. This is the statement of the mean value theorem if the function is nice enough, that is, it has continuous derivative, and that is actually given in our problem. Now it says that if you look into the problem, it says that the derivative is between 0 and half. The absolute value of the derivative is between 0 and half. So we are defining a sequence of real numbers. a1 is equal to 1 and an plus 1 is equal to f of an. So it's a sort of a nesting is going on. For example, if you find out a2, that is simply f of a1, which is 1. a3 is f of a2, which is f of 1, so f of 1, and so on. So you are repeatedly applying the function f on 1. We are repeatedly applying. So this is a very delicate method, and it appears over and over again in many problems, that you repeatedly apply a single function on a particular input value and you see how the output behaves. So instead of going into the final solution of the problem, I want you to imagine what's going on really with a single line. Let's draw this as a real line, and this is the input point, which is 1. Now this is not only for this problem, this is for any problem which has a similar taste. So what you're doing is you're applying the function f on this point 1, and suppose it jumps to some point f of 1. Then you apply f again to this function and it jumps again to some other point maybe. And it is possible that these two, this frog jumping thing happens over and over and over again, and according to this problem, this jumps are happening in between a bounded phase. So maybe these points are jumping, but these jumps are happening between some minus m and positive m. So that's what we are trying to show here. That's the intuition of this problem. You're repeatedly applying the function f. It's the point 1 is frog jumping from one, maybe zigzagging along the real line, but it's contained between minus m and plus m. All these jumps are contained in between minus m and plus m. Hence, absolute value of an, which is nothing but you are applying the function n minus 1 times or n minus 1 times on 1, right? A2 is 1 times f, A3 is 2 times f, and so on. So think about this problem. We will solve it fully in the next installment. The link is in the description. Thank you.